right, so now we're going to divide rational expressions and also rationalize denominators when that happens. So there's going to be a couple examples on here. First, the steps for dividing rational expressions are similar to multiplying. You're going to work with the coefficients, you're going to divide the inside of the radicals, and you're going to simplify or rationalize, which I will explain in a minute. Keep in mind that if you have like the square root of something, like I'll just do something like this, over the square root of something else, it's the same as having the square root of the fraction. So that is a good rule to keep in mind. Also, rationalizing we use when there is a radical in the denominator. They're not really allowed to be a radical in the denominator in a final answer. So when there's a radical in the denominator at the end, that's when you rationalize. And I'll give you some examples of what that looks like so that you're not like, what does she mean? All right, so first, let's look at the first example. This one's the simplest type of example. So we're going to divide the coefficients. So that's going to be 6. And then we're going to divide the inside of the radicals. So basically what you're looking at is this problem. All right. And 160 divided by 5 is 32. So we have 6 root 32. At that point, you're going to simplify the inside. So that's going to be 16 times 2, which remember is the square root of 16 times the square root of 2. The 6 from here, outside, the square root of 16 is 4 and root 2. So that's going to be 24 root 2 for the final answer. And that's the simplest version of how to do it. Let's look at the next one. This one, we have no coefficients, and I'm going to rewrite it this way only because I like to do that. Not everybody likes it, but for me, it's helpful. All right, so I'm going to simplify now inside the radical. We're going to follow the laws of exponents. When you divide, you subtract. So we have the square root of x, because 3 minus 2 is 1, and y, because 9 minus 5 is 4. Remember, this means the same as looking at it that way. The square root of x is not simplifiable, but the square root of y to the 4th is y squared, because we divide 4 by 2. That's it. It's done. So divide the coefficients, divide the inside of the radicals, and then simplify and rationalize if you need to. All right. This one is already inside the radical, and that is where we're starting. So we're going to simplify the inside. And really, there's nothing to simplify here, it looks like. So I'm going to kind of pull it out. I'm going to show you my thought process as I go and see where we land. To me, I want to kind of look at it as two different pieces because this is not something that we can work with together. So it's a cube root. In this first one, the cube root of 7 can't be simplified. X to the 5th, remember, is made of x to the 3rd and x squared. It's a cube root, so that x cubed can stay on the outside and the x squared on the inside. And in the denominator, 64 is, let's see, 32 and 2, 16 and 2, 4 and 4, 2 and 2. All right, so factor tree there. So, and we have y to the 6th. So I know I'm going to end up with y squared on the outside, 6 divided by 3. And every 3 2's can go on the outside. So apparently my brain had forgotten that that 64 is a perfect cube. But that's okay because this is how I worked around it. So again, it's good to have them memorized, but this is what happens if you don't, and it's not really a huge deal. All right, I kind of went through that fast, so if you have any questions about that, let me know. This one has like a warning sign, and that warning sign is that we have a radical in the denominator. That is not acceptable, so we need to figure out how to reverse that. In order to reverse it, we're going to multiply the denominator by the square root of 5, because if you multiply the square root of 5 times the square root of 5, that's going to be the square root of 25, right? Which is just 5. But whatever you multiply the denominator by, you have to multiply the numerator by. So we have 3 root 5 over 2 times 5, because again, the square root of 5 times the square root of 5 is 5. So 3 root 5 over 10 is the final answer. All right, one more. So this one is a little bit more complicated. We can't just multiply by the square root of 6, because then it's going to have to be distributed, and we're still going to have a square root of 6. So what you do is you multiply by the same everything except you change the sign. This is going to cancel that middle term, which is the one that will contain it. And we have to do the numerator and denominator by the same thing. All right, so now we kind of have a lot of side work to do. We need to multiply the numerators, which I'm going to do right here. You can use FOIL, or you can use the box, which is what I'm going to use because I think most of you are more familiar with that. So for the numerator, we have 8 and the square root of 6, 3 and 4 root 5. 8 times 3 is 24. This will be negative 3 root 6, 32 root 5, and negative 4 root 30. All right, we're going to pull that out. So our numerator right now is 24 minus 3 root 6 plus 32 root 5 minus 4 root 30. And we will go through and try to simplify if we can. In the denominator, we're going to do the same thing. We're going to make a box, and we're going to put in our headings. 3 times 3 is 9. 3 times negative 4 root 6 is negative 12 root 6. This is going to be positive 12 root 6 and negative 16 root 6. When we put these here, 9 minus 12 root 6 plus 12 root 6 minus 16 root 6, you can see that these two middle terms will cancel. All right, so far in this one, we cannot combine like terms. 30 is 5 and 6, 3 and 2. So this is actually as simplified as possible on the top, which is actually pretty hideous. Whew, I ran out of room. And on the bottom, we have 9. Oh, what in the world did I do? Root 6 times root 6 is root 36 right here. So we really have negative 16 times 6 is 96. So we have 9 minus 96. So our final answer is 24 minus 3 root 6 plus 32 root 5 minus 4 root 30 all over 9 minus 96, which is negative 87. And that is hideous, but that is the answer. All right. Have a great day. Bye.